When we come to class 10 insight, in today's class we shall be discussing few of the important activities from your examination point of view. This is the important activities part 2 video, even the part 1 video which has all the important activities in that. You can check for the link in the description box. It will definitely help in your exams. First, let us understand what is this experiment all about. Then we will discuss what are the different types of questions would be asked. So observe the diagram carefully. Here we have a complete circuit in which we have XY, the straight conductor, or generalized we will take it as a conductor. We have got a cardboard that is fixed perpendicular to that, and we also have a rheostat or the variable resistance connected. We have an ammeter connected in series with the battery. We have a battery here and the plug is closed, which ensures that there is the flow of current through the conductor XY. Now, we can observe here in this cardboard which is placed perpendicular to that of the conductor, the compass needle is placed. On passing the current, through the conductor, we observe that the magnetic compass needle deflects. As soon as we stop the flow of current, the deflection also stops. So when current is stopped, the magnetic needle which is going to deflect, the deflection also stops. What does that mean? A current carrying conductor, with respect to this experiment, that is when we pass current through this conductor XY, we observe that the magnetic compass needle is deflecting. When will this magnetic compass deflect? Only when there is a magnetic field around that. So, a current carrying conductor produces magnetic field around it. Very important activity. You tend to get confused and you write the straight conductor carrying current and the pattern of magnetic field will be concentric circles. Many students get confused with that activity. That is there in our part 1 video. You can just have a look over there. But this experiment is all about the current carrying conductor produces magnetic field around that. As a result, we can see that the magnetic compass needle will deflect. Hope the experiment is clear. So what are the different types of questions that can be asked? Describe an experiment to show that electricity and magnetism are linked to each other. If this is the question asked, you have to describe this experiment with the diagram. So this is one of the questions that can be asked, or else directly they can ask that, prove that, describe an experiment to prove that a current carrying conductor produces magnetic field. So these are the two questions that can be asked. They might ask you as, describe an experiment to show that electricity and magnetism are linked to each other. Are they linked to each other? Yes. A current carrying conductor, when there is current flowing through this conductor, there is deflection in the magnetic compass needle, which proves that there is magnetic field produced around it. Or else they can directly ask it as, describe an experiment to prove that a current carrying conductor produces magnetic field. So the magnetic field will deflect only when current is going to pass through this conductor. If at all there is no current flowing through this, the compass needle also will not deflect. So these are the two types of questions that can be asked with respect to this activity. Hope it's clear. Now coming to the second activity. Here also first we understand how the experiment works, then we will see the expected questions or the different types of questions that can be presented. You will be knowing the activity, but the trick is how you understand the question. The paper setter will definitely twist questions in these activities itself. All the application type of questions are also are always based on activities. If at all they ask directly to describe the experiment or the activity, then also you will have a key point which will relate you to the given activity. So let's start with the activity. Here we have two circuit diagrams. First, let us observe here. We have a battery. The plug key is closed. As a result, it ensures the current is flowing. So the current flows from positive to negative. And we have a compass needle here. When we observe that, and this is the conductor. So with respect to conductor, if this is the north and this is the south, so keeping these directions in mind, when the current is flowing through the conductor in this direction, that is, it is flowing from north to south. At that time, it is observed the magnetic compass needle deflects towards the east. When the direction of current is flowing through the conductor, this brown colored wire I consider as a conductor, through which I will be observing the direction of current and the magnetic field. So when the current is flowing downwards, that is from north to south. From north to south, the current is flowing. At that time, we can see the deflection of the compass needle. Why do we observe the deflection in the compass needle? We just discussed in the previous activity. Now, we are observing the direction in which it is deflecting. It is deflecting towards the east. In previous activity, we just discussed that a current carrying conductor will produce magnetic field. As a result, the compass needle will deflect. Here also, on passing current through the conductor, the magnetic compass needle will deflect. But we are observing the direction also. We are observing the direction of current as well as the magnetic field. So when the direction of current is from north to south, the compass needle will deflect towards the east. Coming to the second trial. Here we have interchanged the positive and the negative terminals of the battery. As a result, what happens? The current flows in this direction, that is from positive to negative. So it is in the reverse direction compared to the first trial. So what is happening when it is what happens when the current flows in this direction? The current is flowing from keeping this directions as a reference point. Now the current is flowing from south to north. From south to north, the current is flowing. The arrow mark also is very clear. So the current is flowing from south to north. We observe that the magnetic compass needle will deflect, but it deflects to the west direction. Hope it's clear. So in this activity, we are observing the direction of current and magnetic field. When the direction of current is changed, the direction of magnetic field also changes. That is why the compass needle, which was deflecting towards east, is now deflecting towards west on changing the direction of flow of current. So what are the questions that can be expected with respect to this activity? Describe an experiment to show that direction of current and magnetic field are dependent. They can ask in this way, or else they can also ask us, describe an experiment to show that direction of magnetic field changes when the direction of current changes. So these are the few type of questions which we can expect to describe this experiment. So if you know the complete diagram clearly, it is very easy to explain in your own words. So that is why I always suggest you to practice diagrams along with the arrow mark. Without arrow mark, there is no value for your diagram, and also you cannot judge, and the evaluator also cannot judge whether you have understood the experiment or not. If you forget this arrow mark, you even tend to mention this point that the magnetic compass deflects towards the west. So see, all these arrow marks are very much important. So first, please Pay attention and give importance to the diagram along with the labelings and the arrow marks. It will definitely help you to build your answers with the key points as we have discussed now. Coming to the next experiment. If you observe the diagram, you would have already got an idea. This brown colored coil of wires is our conductor. So this experiment is all about the circular shaped conductor. So what happens? You see the arrow mark here. We will come to know the direction of flow of current. We have a complete circuit here. I have a circular coil for which in the perpendicular position we have a cardboard fix, and we will sprinkle iron fillings over here on connecting it to the circuit, and the plug key is closed, which ensures the current is flowing through the circuit, and the direction of flow of current is from positive to the negative terminal. So this is the direction in which the current is flowing. It flows from positive to negative. So this is the direction of flow of current. What do we observe when the current is going to flow through this conductor? In straight conductor, what did we observe? We have discussed in the part 1 video. We observe that the magnetic field will be in the form of concentric circles. Now, here also, on passing current through the current carrying conductor, which is circular in shape, we know that every current carrying conductor will produce magnetic field. But here we are worried about the pattern. We are changing the shape of the conductor also. Earlier it was a straight conductor. Now we have a circular conductor. So we will be observing the pattern of the magnetic field lines. On observing here, you can observe in both these edges we have concentric circles. That is, circles of different radii with a common center. We have it here. And as we go to the center, we see that the radius of the concentric circles are also getting increased, and at the middle it is a straight line. Hope it is clear. I repeat, we have changed the shape of the conductor. Earlier it was a straight conductor, now it is a circular conductor. Irrespective of shape of the conductor, every conductor which carries current will definitely produce magnetic field. In the same way, here this circular conductor will produce magnetic field around it. That is why to observe that pattern, we have fixed a cardboard perpendicular to that, and we have sprinkled iron fillings on that. When the current flows through the conductor, we observe that there is a pattern of concentric circles, and as it moves towards the center, we observe that the concentric circles radii is increasing, and when it is tend to join, they also form concentric circles. But at the center, we observe that there is a straight parallel line. Hope this activity is clear. So, even here, if we apply right hand thumb rule, it is very easy to observe that every point of the circular conductor will produce magnetic field around that. It will also help us to find the poles. And one more important point we have to remember in this activity is, on increasing the number of turns, if you are going to increase the number of turns of the coil, if you are going to increase the number of turns of the coil, what do we observe? That current is increased. So if the current is increased, in turn what will happen to the magnetic field here? It also increases. So you can get any of the MCQ based on this activity. So how will you increase the magnetic field or the current in a circular shaped conductor? It is by increasing the number of turns of wire. Hope this activity is clear. So in this activity, we are observing the pattern of the magnetic field lines when we are changing the shape of the conductor. That is, the shape of the conductor is circular in shape. Hope this activity is clear. Coming to the next activity. So this is the most important activity. One definite question based on this will be there. It could be either 1 mark in MCQ, or else direct experiment for 3 mark, or a 2 mark question asking how will a solenoid behave as a bar magnet. We have a detailed video in our channel. You can just have a look. In our channel, if you observe the first videos that is posted in our channel, are very important. There is no question paper in this state syllabus question paper without the concepts we have covered in the first 5 videos. That is how we are focusing on. We are focusing on all the important concepts and the difficult concepts which will help the students during their exams. So if you just have a look, go and check first 5 videos in our channel. Every question paper has these topics in their questions. It could be in 1 mark, 2 mark or 3 mark as well. So one such topic is our solenoid. So what do we observe here? First, we will observe the shape of the conductor. We have the coil of wire that is coiled in the shape of a cylinder. So what is the shape of the conductor we are going to deal in with this? We are going to deal in this experiment is a circular shaped conductor. In the part 1 video, we came to know about a straight conductor. Now, just before this activity, we discussed about the circular shaped conductor. Now we are going to learn about the cylindrical shaped conductor. So what are we observing here? Here also we are observing the pattern of the magnetic field lines on changing the shape of the conductor. So from circular we have changed it to cylindrical shape. That is the coiling of the wire will be done in this shape. So what do we observe on passing current through this conductor? So this is the flow of current. It is flowing. If you see the arrow mark, it is very clear. Here also each and every arrow mark is important. That will clearly give you a picture about how the experiment works. On passing the current through the positive terminal, this is how the current flows. As a result, we observe that the magnetic field lines here at the center, they are parallel to each other. If you observe, they do not meet anywhere. They are parallel to each other at the center. What does that mean? It says that the magnetic field at the center of the solenoid is uniform. It says that at the center, solenoid is nothing but a cylindrical shaped conductor. We have found that on passing current through the solenoid at the center, the magnetic field lines are parallel. If the magnetic field lines are parallel, what do we conclude from that? It is the magnetic field is uniform over there. Next, when we observe the direction of magnetic field here, they are emerging from north and they are merging here at south pole. So we consider this as north and south pole just as similar to a bar magnet. If at all I bring a bar magnet here and keep the bar magnet whose north and south pole is already known, I observe that these two are going to repel, which states that even this is behaving as a north pole of a bar magnet. So a cylindrical shaped conductor known as a solenoid behaves as a bar magnet. So this is a frequently asked question. Also, it was asked in the recent model paper. How do you prove that a solenoid behaves as a bar magnet? So these are the points which support your answer. Then next, if at all I get a bar magnet facing the south pole towards this end, we find that it is getting attracted towards the pole. So we came to know that these are unlike poles. So this is how I can make out which is the pole of the solenoid which is behaving as a bar magnet. So which are the properties similar to a solenoid and a bar magnet? We observe that even in a bar magnet, suppose this is north and south, the magnetic field lines travel from north to south. Even in the same way, even here, the magnetic field lines are traveling from north to south. And we know that inside the bar magnet, the magnetic field lines travel from south to north. Even here, they are traveling from south to north. And even in the bar magnet, nowhere the magnetic field lines, they intersect each other. They are parallel to each other. They do not merge at any of the point. Same way even here they are parallel to each other and they do not meet anywhere. So these are the 3 points which will support your answer how a solenoid behaves as a bar magnet. We have a detailed video, you can check. So now let us focus on the magnetic field pattern. So the cylindrical shaped conductor is known as a solenoid. On passing current through that, we observe that the magnetic field lines are produced inside the conductor as well as outside. So they tend to emerge from north pole from one end of the conductor, and inside the solenoid they are straight lines which are parallel to each other, stating that the magnetic field inside a cylindrical conductor is uniform. Even here also, how will we increase the magnetic field strength is by increasing the number of turns of the coil. When we increase the turns of the coil, the flow of current will increase. As a result, the magnetic field will also increase. So this strong magnetic field that is produced inside the solenoid, it can be used to magnetize a piece of magnetic material like soft iron. We can use a soft iron. So if it is placed inside the coil, soft iron, if at all, if it is placed inside the coil, then it starts behaving as an electromagnet. This is very important point. If at all they ask the question as describe an experiment of preparing an electromagnet. So this is the activity you will be describing. How will we prepare an electromagnet? We will make use of the strong magnetic field that is going to be produced inside a solenoid. We will be placing a soft iron and we will allow the current to pass through the solenoid. As a result, what happens? The soft iron that is placed here, it starts behaving as an electromagnet. As soon as we stop the flow of current, it stops behaving as a magnet. So it is a temporary magnet. So these are the different type of questions that can be asked. So as I said, the bar magnet experiment, how we are going to check the poles also with that soft iron core, if we are going to do, we will come to know the poles of the magnet and how it behaves as a bar magnet. So what are the questions that can be asked based on this activity? Describe an activity to show the magnetic field lines in a solenoid or a cylindrical shaped conductor. Both the ways they can ask the question. Describe an activity how an electromagnet is prepared. So that is one of the questions. Describe an activity to show that how a solenoid behaves as a bar magnet. How they are. Or one more question is a solenoid and a bar magnet similar in their properties? If so, justify your answer. See, they can ask in various types of, based on one activity, we can frame 5 to 6 type of questions. If you know the activity along with the diagram perfectly, it is easy to tackle the question. Hope it is clear. So be alert when you're reading the question and relate it to the activity. You will be knowing the activity, but you have to judge which activity for which question. That is the reason I have told all the expected different methods of question that can be asked with respect to these activities. Hope this video is useful.